All right, so we're on 6.07 today, and I did attach this, or I will attach this to the post. So you can print it out, and I tried to give it out in class. If you got it, then you can use that, or you're welcome to print it out or write on Cami, or you can also just write it on loose leaf. So solve each of the following using vectors. These are tension word problems that have one variable. So we've got Wile E. Coyote is hanging an anvil above the road in hopes of catching Roadrunner. Two ropes are being used to support the anvil. The ropes are both making an angle of 35 degrees to the horizontal. If the tension in each rope is 67 kilograms, what is the weight of the anvil to the nearest 100th kilogram? If you need to, pause the video here, reread that over to yourself as well. We're going to start by drawing a picture here. So I'm going to draw my picture down here. So this is going to be, I'm just making up letters here for A, B, C, and D. So we've got, and your picture is always really going to look the same. And then we have this anvil we're going to call is D, hanging down here. So the weight is pulling down. And so we're going to do this problem using vectors. And we've got A, B, C, and then D is this point down here. And we're told that the two ropes are making an angle of 35 degrees with the horizontal. So here, this is one rope, and this is the other rope. And those, the horizontals right here, so they're each making a 35-degree angle with the horizontal. All right, and the tension in each rope is 67 kilograms. So that's going to be our magnitude of the vector. So we know each of those is 67. And they're equally pulling away from as this anvil hangs. All right, so now we want to use our angle vector form because we have angles that are formed with, and we can draw in a positive x-axis. So angle form for this, which, and again, that angle is formed with a positive x-axis is really important to remember here as well. So that formula is the magnitude of vector v times cosine of theta. So the theta is that angle formed with the positive x-axis. And then the magnitude of v times sine of theta. Again, theta is that same angle. All right, so now let's look at our picture and figure out an equation that we could use to represent this so that we could find our missing pieces. So we could take vector CA plus vector CB. So CA and CB, those are pulling in the opposite direction as CD, so those need to equal each other. And you talk a little bit more about all of that in physics too. But, you know, if something's pulling down, then it has to be pulling up in the opposite direction for it to stay there. All right, so now let's write a vector for each of these. So vector CA, so that's this one over here. So if we're using this format right here, the angle vector form, we need the magnitude. Well, we know we were given the magnitude as 67 times the cosine of the angle it forms with the positive x-axis. So to figure that out, I want you to kind of envision here your x-axis is right here passing through point C. And just to get the idea here, you also can envision your y-axis right there. So if I want to figure out what this vector right here, the angle that vector CA forms with the positive x-axis, which is over here, this is the side that's positive, just like when we measure any angle, it goes counterclockwise from that positive x-axis. So that's our theta. We need to find that angle. All right, well, we don't know that angle at this point, so what can we find? Well, I know that this angle up here is 35, and this is a horizontal line, as is the positive x-axis, so then you can look for your z. And so I know now this little angle right here is 35. I also know over here I have another z. with those same two horizontals. So this is also 35. But again, that's still not the angle that I'm looking for. I'm looking for this angle that goes from here all the way over to here. So to find it, what we could do then is we could say, well, we've almost gone a full 180, except we didn't have this angle right here. So you could subtract 35 from 180. And that's going to give us 145. So now I know that that whole angle right here is 145 degrees. Some students also like to add up 35 and 35, and then subtract it from 180 to find this angle, but then you'd have to add that to the 35 as well. But that would also work in this case. All right, so now I know my angle is 145 degrees, so then I'd have 67 times sine of 145. That's vector CA. Now let's go on to vector CB. So that's this one right here. So again, my magnitude is 67. This time, the angle that it makes with the x-axis is a little easier to find. We already have that labeled as 35. And sine of 35. And then let's write a vector for CD. So this one going straight down right here. So since it's going straight down, it only is going to have a vertical component. So remember, this first part is your horizontal component, just like if you were to graph an ordered pair like x, y. First you go left, right, then you go up and down. So the same idea here, which means we have 0 for our horizontal component. And then to find our vertical component, which is what we're actually looking for, so you only have a vertical component because it's being pulled straight down. Okay, so now what we're going to do is we're going to just add straight down here. Gotta go grab my calculator. Okay, so just to show you here, you could, first of all, make sure your calculator is in degree mode. Mine is. And then we're adding straight down because we want these two vectors to equal vector CD. Again, they're pulling in those opposite directions. So we've got 67 times the cosine of 145, close my parenthesis, 67 times the cosine of 35. And that gives me 0. So you can see here those two add up to 0. Now let's do the other side to figure that out. So 67 times the sine of 145, make sure you close your parenthesis, plus 67 times the sine of 35. And we get 76.85924,247. And we want to round this to the nearest hundredth of a kilogram. So our final answer would be 76.8 hundredths here, so 86 would be your final answer. Okay, so again, a couple things that are going to be consistent with all these problems. Your picture is going to look pretty similar. You're just going to have some different angle measures and magnitudes labeled. We're going to be using this formula for our vector on all of these. And then here, this equation right here, whether you change the letters or not is fine, but this standard setup will be the same. Then you're going to write a vector for each of them and then add them together. So let's try another one. So here we have Gabriella, Leia, Bella, and Maya decided to do a pre-calc experiment for fun, obviously. They found a 160-pound weight lying around and used 2 ropes to support it from the ceiling, as shown in the figure below. So again, you see this similar figure. Find the tension in each rope, and I would like you to do this one without a calculator. So first, let's label, let's call these our A, B, here's our C, and then down here, the weight that they found going towards D. All right, we know that the weight is 160 pounds, and Find the tension in each rope. What was on this picture that got cut off actually was that each of the ropes is going to make a 30-degree angle with the ceiling. So that would be added into the original. It was on the picture, but the picture it got cut off of. All right, so now we know that we know the angles and we know our weight pulling down. So a little bit different than before, but again, still the same setup. So we're still going to take vector CB and vector CA and set them equal to vector CD. We've got vector CA, vector CB equals vector CD. So now let's write out a vector for each of these. So vector CA is right here. So we don't know the magnitude this time, and let's call that our X, since that's what we want to find. We want to find the tension in each of the ropes. And these, since we know this is an isosceles triangle, since both angles are 30 degrees, we know that they're going to have the same tension in each of them. So that makes it a little bit easier. The next ones we'll talk about have two different variables in them. All right, so again, if it helps, you can go ahead and draw in your X and Y axes, because remember we need to find for this one CA, the angle that it forms with the positive x-axis. So here we know this is 30 and this is 30. So we can again do 180 minus 30, 180. So from pink to pink is 180. Subtract out that 30 to get our angle of 150 degrees. So here we know it's the magnitude or the tension is X times the cosine of 150, and then X times the sine of 150. For vector CB, this one makes an angle of 30 degrees with the positive x-axis, so this would be X cosine 30 and X sine of 30. And then vector CD, again, we're going to just add these together, and they need to equal this vector. But this vector here, we know is pulling straight down, so we know this has to be 0, and the vertical component is 160. All right, so we need to find X. So this one, again, is slightly different here, but we have a nice set of equations right here that we can use to solve for X. And because there's only one variable, you're only going to need one equation. Where next we'll talk about two different variables, so you'll need two equations. And that all is because you have the same angle, because you've got that isosceles triangle given here, that they are both 30 degrees from the horizontal. All right, so now let's go ahead and solve this equation. So I've got X sine 150 degrees, plus X sine of 30 degrees equals 160. It said to do it without a calculator, so you might need to draw out your angles here. So 150 degrees is in quadrant 2. It has a reference angle of 30 degrees, which we found over here too. Drop my perpendicular. I've got a bow tie triangle. That's in a ratio of 1, 2, rad 3. The rad 3 should be negative. And then the sine of that would be opposite over hypotenuse, so that's 1/2. So sine of 150 is 1/2 times x, so 1/2 x, plus the sine of 30 degrees. So here's your 30-degree angle. Drop your perpendicular. And opposite over hypotenuse would be 1/2 again, so that's another 1/2 x. Add those together, 1/2 plus 1/2 is 1x equals 160. pounds would be your final answer. And you do have to show all of that work here to find your value for x to get that. All right, so that is if you have two different types of setups if you have one single variable. The next problems, we're going to do two more, and the next two are if you have two variables. So they're going to be a lot longer problems, and the setup will still be the same in the beginning, but since we'll have two variables, we're going to need two equations, and we're going to have to solve that system of equations, and it's just, there is a lot of work involved, a lot of decimals. It can get a little bit messy. So really important to just keep everything really neat and organized as much as possible. All right, pause the video here and read the problem. All right, so we've got Kate needs help lifting a weight of 18,500 pounds, but her own personal crane is not enough, so she calls Madison, who also has a personal crane, luckily, and Kate's crane is lifting the object from the left, so over here we have Kate, and then over here we have Madison. And we're going to draw our picture here again, so let's just connect it right here. So this we'll call our A, B, and C, and D down here, which we know is 18,500 pounds. All right, and we also know here that Kate's crane is lifting the object from the left at an angle of 22 degrees with the horizontal, so we know that's 22. Madison's crane is lifting the object from the right at an angle of 38 to the horizontal. We want to find the tension in each crane, so I'm going to call that X and Y. So before we were able to call them both X, that was because it was an isosceles triangle. These two angles were the same. Here, our angles are not the same, so these are going to be two different values. All right, and we can set up our equations as well, and to do that, it might help you to draw in your axes here and figure out the angle that each vector is forming with the positive x-axis. So here, this vector CA. So to find that, we look for our z angles first. So pause the video here and try to find the angle on your own. So this should be 38. This one is 22. So to find that full angle, we would do 180 minus 22, which gives us 158 degrees for that angle. All right, so now go ahead and do this setup. I'd like you to pause the video and write out your equation for your vectors and write out the angle form for each of those three vectors. All right, so we should have had here vector CB plus vector CA equals vector CD. And now we want to write a vector for each of them. So hopefully you've already done this part. So CB, I started with this one this time, so it has a magnitude of x, and the angle it forms with the positive x-axis right here is 38 degrees. And then it would be x sine 38. And usually CA is our hardest one to do. So that one we have magnitude of y, and this one, again, is forming this whole angle with the positive x-axis. So this purple angle right here, that's the angle that's forming with the positive x-axis. So we're not looking for this 22, we're looking for that 158. And y sine of 158. And then vector CD is we're pulling straight down. So just like all those ones before, this should equal 0. And if we add these together, that should add up to the weight, which is 18,500 pounds. So now we've really set up, we've got two different variables, x and y, and we can set up two different equations. So I have one here, and I have one here. All right, so let's start by just writing out those equations so we have them. So x cosine 38 plus y cosine 158 equals 0. And then I also have x sine 38 plus y sine 158 equals 18,500. And I would recommend, because these do get a little messy, I think the easiest way to do these is by substitution. All right, so to solve by substitution, we need to solve one of them first for x. So I usually take this first one since it's already equal to 0, and I'd solve that for x. So solve for x. So I'm going to first subtract over that y cosine 158. And then to solve for x, I'm going to divide both sides by cosine of 38. So I have x equals negative y cosine 158 over cosine 38. So now I want to take that, which is equal to x, and everywhere I see an x in the other equation, so the second equation, I want to substitute that in for x. Okay, now I'm going to bring my work up to here. All right, so now, and again, we might want to make a note, two variables, therefore need two equations, and that's because you have different angles formed with the horizontal. All right, so now let's take this negative y cosine 158 over cosine 38, and I put that in for my x right here. So now I'm just going to write the rest of the equation out. So times sine 38 plus y sine 158 equals 18,500. So I need to solve for y, and as you see, I have a whole lot of stuff going on here. So what I'm going to do is I see a y in each of them. So I'm actually going to factor out that y. So I'm going to factor out the y, and careful here because this still has a negative right here. So in parentheses, if I divide this first term by y, I'm just going to be left with everything else. So negative cosine 158 over cosine 38 times sine 38. Plus, here, if I divide this one by y, then I'll be left with just sine 158. All right, now from here, all of this can be typed right into my calculator. I have no variables in there anymore. Be really careful, though, because a lot of times this is where students run into problems, is just not being careful in their calculator. So again, make sure that you're in degree mode. You make a note so you don't forget that. And let's go ahead and type it in. So alpha y equals, I've got negative cosine 158 over cosine 38 times sine of 38 plus sine 158. Be careful with closing all of your parentheses. So I get 1.09900 2012 equals 18,500. And now we're just solving for y. So we're going to divide both sides by that decimal. And again, that can be done right in your calculator. So 18,500 divided by my answer up here. Always, of course, write out your entire decimal. And then in this one, it said rounded to the nearest tenth of a pound. So then we can round to 0.5. So that's one answer. And now we need to find x. So not as much work, but again can be a little tricky because there's so much going on here. So now we're going to sub in to find x. So I'm going to use this one over here because I already have it solved for x. So I'm going to take x equals negative this answer times the cosine of 158, divide that by the cosine of 38. Okay, so in my calculator now, I'm going to do negative my answer times cosine 158. Also, remember, you do want to use that full decimal and then divide it by cosine 38. You also could have used alpha y equals here. 6, write out your full decimal, and then round to the nearest tenth. And that's your value for x. So it is a long problem, a lot of tedious work, but all things that you can do, the substitution and stuff like that, you guys have done that a lot. And this part should be the same as the front problems. All right, let's do one more of these. We've got Gabe, George, Josh, and Joe are hanging up a block from 2 ropes for an experiment in their pre-calc class. Also so much fun. The block weighs 2 kilograms. If the angles formed by the ropes and the ceiling they are attached to are 40 degrees and 60 degrees, what's the tension in each rope? Round to the nearest thousandth of a kilogram. So pause your video here. I'd like you guys really to go as far as you possibly can. It's going to be just like the last one we did, but at least get to a point where you've written out, drawn your picture on your own, write out the equation and write out the vectors, and maybe even set up the equations on your own. All right. Let's see. We know one of the angles is 40 and one is 60. So we've got vector CA plus vector CB equals vector CD. And you should have written out a vector for each one. So again, if it's helpful for you, draw in your axes. And then CA is forming the angle you want formed with the positive x-axis, so this one. So here we know this little angle down here is 60. This angle with all interior angles is 40. So 180 minus 40 gives us 140. So I know for vector CA, and these have 2 different angles, so the magnitudes, the tensions in each rope is going to be different. So we'll call one X and one Y. So for CA, that one's going to be Y times cosine 140. So make sure you match up your variables appropriately. And of course, it's always probably the most common mistake is getting this angle wrong right here. People try to use like the 40 instead of 140. So really focus on making sure you have the proper angle there. And then vector CB would be x times cosine 60, since that's the angle it makes with the positive x-axis, and x sine of 60. And then vector CD is going straight down with 2 kilograms in the vertical direction. All right, so if check this, hopefully with what you guys have. Now, if you haven't already, pause the video, write out your 2 equations, and see if you can solve it on your own. All right, so again, to get your equations, you're going to add these and set them equal. So here's one equation, and here's your other equation. So we've got, I'm going to put, just because I like the x, it doesn't matter, we'll do y first. So y cosine 140 plus x cosine 60 equals 0, and y sine 140 plus x sine 60 equals 2. So now we're just going to use substitution to solve. So here I'd really like you to try it on your own, see if you can solve for x. I like to use this first equation that is equal to 0, a little bit easier, and substitute into the other equation. Again, a lot of calculator work here. So pause the video and try to do this on your own. All right, so I'll go kind of quickly through it, but again, you want to take this one and solve for x or y. It doesn't really matter. I'm going to solve for x just to be consistent with what we did before. So I'm going to subtract the y cosine 140 over. So y cosine 60 equals negative y cosine 140. Divide both sides by cosine of 60. And I have negative y cosine 140 over cosine 60. So now everywhere I see an x in my other equation, I'm going to replace it with that. All right, so actually I'll go up here next. So now I have in my second equation y times sine of 140 plus, and taking out my x, replacing it with negative y cosine 140. If you had done minus, that would be fine there too, times sine of 60 equals 2. So I got the sine of 60 right here. So in for x, I just put this in right here, times sine of 60 equals 2. Now the whole equation is in terms of y. And then what we did last time was we said, well, each of them have a y, so let's factor out the y. So if I factor out a y, divide each of these by y, what would I have left? Well, I'd have sine of 140. Instead of doing plus and negative, I'm just going to say minus, so the y would cancel or factor out, times sine of 60 equals 2. All right, now from here, you're going to just type this whole thing into your calculator. Okay, if you haven't already, again, pause the video, do that now. Make sure you're in degree mode. We've got sine of 140 minus cosine of 140 over cosine of 60 times sine of 60, and we get this decimal. So y times 1.969615506 equals 2. And then you're going to divide both sides by that decimal. And we get another decimal. And then this one says to round to the nearest thousandth. So that's 3 decimal places, so 1.015 kilograms for our y. Almost done. Now you just need to find x. So to find x, you're going to substitute in. And again, I like to sub in using this one because it's already solved for x. So x equals negative the entire answer times cosine 140 over cosine 60. Again, a lot of work in your calculator. So alpha y equals, I'll take the negative symbol. Make sure you don't use the subtraction symbol because that is a common mistake that'll cause you to get the wrong answer. And down here I have cosine of 60. Write out our full decimal and round to the nearest thousandth. So 1.55, since that's a 7, it'll go to a 6. So now we found both x and y. So again, a lot of work going on here, but the system, if you just try to keep it really nice and neat and organized, it is going to be the same how it will happen every time. So the more you practice these, the more they'll make sense. So if you're having trouble, feel free to go back and redo any of these, including 1 and 2 where we had just one variable and then you just needed one equation to solve it. All right, and that is it for today. I know this is a challenging lesson, so if you do have any questions at all, of course, please let me know, and we can go over these any more if you need to. Have a great day, and pie out.